Hey software developers, what is going on? I'm the Savage Coder and welcome to episode 22. We're still diving into our JWT Authentication series, so we're going to pick up where we left off. We now have a UI and API that will create users. We have a login system where we can pass our email and password back to the API, and we're able to verify that the password is valid. From there, we have to create a token that we can use and talk about what's going to be in this token and how it all comes together. So I have a couple changes to make that we will speed through. You can just pull down the code. Those changes will pull right down. So as always, github.com/noblecausecode. The card above shows you how to get code for each episode, and all the links you need are in the description. You'll also see on the GitHub site now a database project. If you know how to use that, feel free. I'm going to keep that updated. But I'm not going to go through yet how to use that project because we're kind of in the middle of the authentication thing. So we'll go back and do that afterwards. So without delay, let us get to it. So I just want to start here. The database, I've been messing with it, so I had to kind of clear it out and put data back in. So the seed data file is going to be updated for this episode. So if you go into your API project under data, I'll be replacing the files inside this data folder. It's going to have the schema create, and it'll also have one called seed data. Schema create will create the database for you. Seed data will load it up with data so that you can follow along with the same examples. Or again, you can go to the GitHub site and pull down the database project and execute those SQL files as well. So I wanted to make a couple changes real quick. I thought about our user controller and I decided that I don't want to put all the things that have to do with tokens inside a user controller. User controller should be more about users and not so much about things like authentication or authorization or anything like that. So I'm going to create a new controller called Authentication, and I'm going to move everything that is token related, which is really just this action right here. And instead of calling the user service, I'm going to create an authentication service. So I'm going to do that really quickly so that you don't have to wait. You can pull this code down and I'll pick up so that we don't have to waste so much time with you watching me type things that I've already typed. And then if there's anything special, I'll go over that in a second. Okay, so now where we are here is I just extracted those things from user controller. I have an authentication controller. I created an authentication service as well. And I'm injecting the authentication service, and we're going to create something called request token in that service. There's nothing in there right now. And I've renamed the model to token request from user login. Our token request is going to have the email and the password in it. So we're going to pass those two things in, get back a token. And that's kind of what this line shows. One more thing, the route is just going to be /API/token. Because we're starting with this preceding slash, it will not use the authentication. It won't be authentication/API. It'll just be whatever the URL is, :port, and then /API token. All right, so let's create the authentication service request token async that we have here. That is going to call our user service and get the user based on the email and password we're passing in. And then once we have that, we can use the information from that user we look up and build our token. So in our authentication service, I'm already bringing in the user service. And if you remember from the last episode, our user service has this login user async. So we can pass in our token request and we can use it to return the user. Right now it's returning a string and we're going to change that. We could do that right now. So we pass in an email and we get back the user that matches that email. Emails are distinct in our database system, or they will be. So we can count on if the email matches, there's only one, and it would be the email for that user. So if we can't find one, then we're going to have to not return string.empty. Remember, we're going to change this to be a valid user, which is a domain user in this case. We'll do some mapping later to separate out the domain and API models. But for now, we're just going to use this user. So I can't return a string anymore. And I don't want to return an empty user. Some people do that, where they say, oh, I didn't find a user by this email. The user came back null, so let me just return a new user. And I don't like to do that because it kind of leads you to believe that something worked when it didn't. So I prefer that we just throw an exception. And one of the exceptions that we can throw is an authentication exception. Sorry, I have to throw a new authentication exception. And that authentication exception comes from the system.security.authentication namespace. So I'm just going to use this little quick help to add my using at the top. So cool. If we look for a user by email, we don't find one, we blow up. And then if we do find one, then we take the password from the user from the database, which is our encrypted password, right? If we look in our database, our passwords are these encrypted values. I put the same one for all these users, but normally they'd be different in a live system. So when we pull that user back, it will have that encrypted password, and we're going to pass that to our crypto.verify hash password along with the password that the user is trying to log in with, which is this token request. And so it will tell us whether the encrypted password is a match for the clear text password we're passing in. And as long as it's valid, then we want to return it. We basically want to say if it's not valid, then we also want to throw an exception. Otherwise, if it's makes it past those two checks, we're just going to return the user. And so now our login user will look up our user, verify the password, and return it to us from whatever calls login user async. Well, that's what we want to do inside our authentication service. Let's create our method for the authentication service. Now, if you remember in our authentication controller, we're calling out to request token async. So this is really what we're building here, and it's going to take in a token request. So let's go into our service and make a public async task of, well, we're going to have to create some kind of a token. So let's just say token response for now. We haven't created that yet. And it's just going to be a model that holds our token, which is just a string. We want to call that request token async, and we said it's going to take in a token request called token request. Let's bring in our token request first. And it's, of course, complaining because we're not returning anything. Let's create our token response while we're at it. So in our API models, I'm going to add a class called token response. And it's just going to have a single property. And we'll just call it, we could call it access token or just token even. So we'll just do a public string token and just a auto property. So very simple. And so now it's happy there, and now we can just call out and do the things we need to do. So we're getting an email and a password. So first thing I want is to capture the user is equal to the user service dot login user async, and we're going to pass it our token request. And this is asynchronous, so we have to await this call. And then we can just check if the user is not null. and we're good to go. And we can start building our token here. So there's a few things we need to do for our token. Let's talk about this token for a second. A token is basically just a standard object that holds information, and we digitally sign with a cryptographic signature this information so that it can't be tampered with. If you tamper with it, it won't pass scrutiny when you look at it to see if it's valid anymore. So I can put something in a token saying my name is Savage Coder. And if you go into that file or that object and you change the name, you can change it. But when you save it, you won't be able to re-sign it with a digital signature. And without that digital signature, I know it's been tampered with. Even if you could somehow replace some of the bits in that file, the actual structure of the object would change in such a way that it would no longer be able to be decrypted. So once we take this information, we use some magic secret and we encrypt our stuff. If you change any of that encrypted value, it won't decrypt anymore. So that's how we kind of protect that JWT token information. And there's also some other things we can stuff into the information so that when we decrypt it, we can also verify whether or not it makes sense. So the first thing we're going to need is a signing key. That's our secret. This is something that you never want to let slip out, because if I give you access to my secret, then you can make changes to things and re-encrypt it, and it'll look like it's from me. So very dangerous for any hackers or anybody who can compromise your system to have access to this secret. For the purposes of this episode, I'm just going to stick this in a constant in this file, and it's going to get checked into GitHub. So obviously you never, ever want to do this in a real live system. Even if you're not in production and you just want to put a development version up, I recommend hiding that secret, and I'll show you how to do that either in the next episode or the one after that. I just would rather get through this token stuff first. So you've been warned. Don't leave it this way, but let's go ahead and create our secret. So I'm just going to do a private constant. It's a string, and we're going to call it JWT signing. Oops, sorry about that. Signing key. Let's make that lowercase. Signing key. And it's going to equal some string value, and we're going to be able to send that key into a symmetric security key system and use that to sign our token. So we need to generate this value. Well, there's a lot of ways to generate the value. I wrote a little quick program for when I need my own, and I will post this on GitHub. It's only 3 lines of code, so this isn't a super secret thing. It's supposed to be easy to generate, and it is. So let me show you how I build mine, and you can either use this method, or I'm sure you can Google things and come up with a bunch of different ways to create your cryptographic secrets. So the first thing we need is a random set of bytes, and we do have the random class in the .NET framework, but it's not as random as the security.cryptography.randomnumber generator. So this system does the best job that C#'s probably going to do for you. And this is actually recommended by Microsoft. So this is one of their libraries, and I think we're safe with it. So we do a randomnumber generator.create. That gives us this RMG, which is just our random number generator. We create a variable that will hold an array of bytes. Think of the array of bytes as a bucket that's going to hold our random secret. So we then tell the generator, get me some bytes, and when you get them, throw them into that bucket. So you're kind of passing the bucket into this generator. And then after that, all we've got to do is convert these bytes back to a string, and we use base 64 encoding, which is going to give you alphanumeric, and it will give us a string we can use as our secret. So if I run this, all that we're going to see is this console.writeLine, and there is our value, right? And that value will be different every time. You see it starts with a little ph and ends with I4 equal. If we run it again, it starts with IUB and ends with KW equal. So this is going to be our secret for now. And we don't need that anymore. And now I'm just going to paste that value into my JWT signing key. Cool? Cool. So the next thing we need to do is we need to create our token, and our token is going to hold a bunch of things. And so we can't completely make it yet, but we can start it. So we're going to make a new JWT security token. And we're going to call the constructor of that. Now, in order to use that, we need to bring in some libraries that do JWT. So we can hover this, and it's going to suggest system.identitymodel.tokens.jwt. We definitely need that one, so I'll select that and find and install the latest version. So we're going to need a couple others, so I'm going to right-click our dependencies and manage NuGet packages, and go to the Browse tab, and we're going to search for Microsoft.ASP.NET Core.Authentication. You see I've used that before, and we'll install that. And then we also want the authentication mechanism for the JWT bearer tokens. And that'll allow us to accept those bearer tokens. Now, you don't have to use ASP.NET Core just to do JWT stuff. You see here we can use OpenID Connect, which will support any OpenID authentication. You can do cookie authentication, general OAuth to support anything that is OAuth 2.0. But there are specific providers if you want to have people log in using Google or Twitter or a Microsoft account. There's a Facebook. And so you can pick the one that works best for you. We're focusing on this JWT bearer because I want to show you how to accept your own users and come up with a good, solid mechanism for logging people in and keeping things secure without any reliance on outside third-party services. If we look at the JWT security token, you can see that there's 4 or 5, there's 5 actually, different overloads for the constructor and what things we can pass in. So I'm going to choose some of those, and I'm going to do them out of order just because it makes more sense for me. And I hope that it's better for you as well. So I'm just going to put these on the next line here. And let's back that up. Okay. And the first thing is the issuer. So I can name my parameter in this constructor by putting a colon. So the issuer is going to be my local host plus whatever port this thing is. So I need to run this just to see what port I'm on. And it's not going to run because I have errors here. It's going to tell me that it can't. But it says, would you like to run the last successful build? That's fine. I don't need any of this stuff to work. I just need this port number. So mine is 44328. Yours will be different. But you should be able to just run your project to find what port you're on. And it's also in the properties launch settings. It should be anyway. And of course, it makes me a liar. No, there it is, 44328. So you can look in there too if you can't run it. But what that says is the system that is issuing this security token is this server. So in our case, the API is going to generate the tokens, but it's also going to accept tokens, right? Because we're going to call out to our API and say, give me a token. And then when we call out again to maybe say, get me a list of products, we're going to pass that token to identify ourselves. One of the things that our API can check when we receive a request, like for products, is, hey, was this issued by the right place? And does the audience match as well? So the issuer is the one that creates the token, and the audience, which in our case is actually the same thing. The audience just says, forgot my comma there. The audience just says, who's supposed to accept this token? Well, in our case, it's the same API. So sometimes you'll have like a third-party issuer where you get your tokens from one server and then you send them to your API, which is the other server that's receiving those. That's the difference between issuer and audience. In our case, they're the same. The next thing that we're going to do is we're going to give it some claims, and we don't have these yet. And now we can tell it how long our token lives. So for my purposes, I just want to make mine live for 30 minutes. After 30 minutes, the token will expire and the user can get another token. And the last thing we have to do is we have to sign this with a credential. And I don't have that set up yet either. So those are the two things we're missing, is the claims and the signing credential. Remember, the signing credential is going to use this signing key to actually sign this whole thing. And then when we decode this later on, we can read the signing credential out of it to see if it's been tampered with. So let's create our claims. So claims is just a list of something called a claim. So we're just going to make a new generic list, and it's going to be of type claim. And let's bring in the using system.security.claims. And so this is just a list, but we can get rid of these parens and use curly braces instead, and we can actually add items to our list in line here. I can just say create a new claim. There's some standards on what we use for claims. So for instance, user ID, unique IDs, names, email, things like that. They have standard places within within the claim to store those name value pairs. So those are built in for us. Kind of hard to remember this one. You might have to look it up, but JWT registered claim names. And if I hit dot, you can see that the IntelliCode is giving me these starred ones because these are the common ones that are in almost all tokens. So sub is actually usually your user ID. Well, we have a user that we created right here. So I can just user.userID. Oh, we've got a problem here. What is this? So it thinks that user is a string coming back from this login user async. So we did not update the interface there. So let's go back to our user service. It is returning a task of user, but I bet if I look at the interface, login user async is still returning a string. So let's bring in that using statement. And if we go back now, this user should be a user. It is. Okay. And all of these claims are strings. So we're going to have to turn user ID into a string, and toString method is the easiest way. And so there's our first claim. The second claim, which I'm just going to copy there, is not a sub. We're going to use the JTI. JTI is generally just a unique identifier of some kind. I don't really have one of those, so I'm just going to generate a new GUID, or a globally unique identifier, as a random kind of string. The next one we're going to get from the claim types. Claim types gives us access to other common identifiers. The two we're going to use here are name and email. So we'll say name is equal to the user dot username. And this claim is going to be of a claim types dot email, and that will be our user dot email. Cool. So now we've got, now we've got a list of claims, and I can take that list of claims and pass it to the claims property in our token. And so now all of these things are going to be available to us when someone calls our API and passes this bearer token. It's going to have the name and the email and the user ID in it. So we'll be able to ask .NET Core anytime we want, hey, what is the user ID, or what is the name of this person? If we want to say, hello, Savage Coder, or we need the email to display somewhere. We have that information. We don't need to go to the database for it. It's in the token with the request. And I'll show you later how to get to that. So the last thing we need to do is we've kind of got our token. We just need to digitally sign it. And we need to put the type of credential that we're going to use to sign it. So first thing we need is our key, which uses the JWT signing key that we created up at the top. So our key is going to equal a new, get ready for this one, I always misspell this, symmetric security key. Let's see if I got it right. Hey, I did. Microsoft Identity Model.tokens. And all I want to send this is, if you look at what it takes a byte array. Well, I don't have a byte array. All I have is this string. So I know I need that. I just need to turn that into a byte array. So we can do that with the system.text.encoding. I should be able to bring in a using for system.text at least. Encoding.utf8.getBytes. So getBytes will take a string and will return a byte array, which is exactly what we need. So now we have our key, and now we need our credentials. And that is a new signing credential. And it takes in first the key that we just gave it. And it needs to know which algorithm to use. So security algorithms dot HMAC SHA-256. This changes over the years as new encryption models come out that are better and more secure. As things become compromised, these things are upgraded. So it's made in such a way that they can upgrade this while keeping it backward compatible by asking you, hey, which one do you need? And so this is the latest, greatest for now. So now that we have our creds, we can put that in our security signing credentials in our token. And the last thing we need to do is we need to generate the token, the actual bearer token, which is just a string, but it's going to contain all this information. So really, we want to return a token response here. And so we're going to return a new token response. In our curly braces, we want to set the property of our token response model we called token. So I'll say token is equal to, and now I've got to call the code that actually generates this token that is digitally signed. And we do that with a new JWT security token handler. So that'll create a new object, and then we call on that object the method write token. And write token returns a string. right? It returns a string, if you can see that, hopefully. And it takes in a security token. Well, we have that. That's our token right here. So I just pass it that object, and it has enough information in it now with these credentials to turn this into an encrypted signed string. Sorry. No semicolons inside initializers. And that's that. The only other thing we really need to do is, if this user is null, what do we do? And I think at that point we should probably just throw new authentication exception. And we'll bring in the namespace for that guy. And I think we're good here. So hopefully that kind of makes sense. We're just bottling up our claims here, and these are the things the user is going to be sending us from the database that we looked up based on their username or their email and password. And then we're going to use our JWT signing key to create some credentials. We stuff all that stuff in the token with an issuer and an audience that we can check. We give it our claims. We set an expiration for how good this thing is, and then we generate a cryptographically signed string that we just assign to a token response object. Yes, I have to look this stuff up every time I do it, and I usually just have to copy and paste things. So you're not expected to remember how to do this, but it's documented out there in many places. So you can refer back to this GitHub or just, Google it and you'll find it. All right. So again, this JWT signing key, we will move out of here and into a safe place in a future episode that happens shortly. So let's see where we are with our token. So we're going to call, this actually we're not going to use anymore. This is the old user controller. I don't want this token. I'm going to comment that for now. Matter of fact, let's just get it out of here completely. Okay. That way we won't make a mistake. The authentication controller is what we're going to call. We're going to pass it request token. Why are you complaining? The interface does not have request token async. Okay. Guess we forgot to change that one too. So let's do that. Oh, it doesn't have anything in it. Let's go back to our authentication controller and oops, there we go. So this is going to have a task of token response. And it's going to take in a token request. And let's bring in the namespaces for those. Good. Cool. So now we're going to call this with a request. We should get back a token, and I'm sticking that token inside the OK so that we can see it. Let's fire up Postman and hit go. I'm going to put some breakpoints in here just in case we forgot anything. I already know something I forgot, so I'm going to stop it right now. Always gets me. If you've been watching this series, you know what I forgot, because I always forget the first time to register my services with dependency injection. So I'm just going to duplicate that line. And I'm going to tell it when you see a request for an authentication service, create an instance of the authentication service. All right. I should have let it blow up so you can see what that looks like, but you've probably seen it before. All right. And I'm not going to update Postman now. So here is my API token. I'm not going to set up any authorization here, so there's no special tokens already in there. There are no headers, just the standard hidden ones. And for the body, I have it set to raw and JSON, and I'm just passing the email and password 123, which does match that cryptographically stored value in the database. So if I hit send, looks like we hit a breakpoint. Let's make sure our data is in the request. It is, email and password. And let's walk it now and go in. And first thing we're going to do is we're going to get our user from the database. Our user is not null. Let's see if it's valid. If I got the password right, true, so good. So our clear text password 123 matches this hashed version that's in the database. It is valid, so it's going to skip that and return the user object. Now we create our claims, and our claims have a username of Savage Coder. It's got my email at Shark Lasers. It's got a user ID of 1, which is in our database. That's the user ID for that user, so we're good there. And now we're going to take that JWT signing key that we generated, create a key and a credential from that, and we're going to create a token object. And the token object, right, has all my claims. It's got 7 of them. So the token also sticks the issuer and the audience inside as claims. And then we will return our cryptographically signed token. I'm going to hit continue. And if we look back at what we get back in Postman, we have our token. And that right there is the bearer token that we'll be able to use to call our API. So we have a full round trip that takes a login and a password and returns us a bearer token. So before we end, I just wanted to show you that I can take this token, just this bearer token part, and if I open up a browser and go to a JWT inspector, for instance, jwt.io, these things are standard. So if I replace the encoded box with my token, you can see that it knows the algorithm I used was the HMAC 256. It is a JWT token. The sub is 1. That's my user ID, right? The JTI is that random GUID that we generated. I have claims where my name is Savage Coder. I have another claim that my email address is savage.coder@sharklasers.com. It expires on this date, which is a Unix epoch date time. And then I have my issuer and my audience. All that came from inside here, and you can see how it's color-coded, that the header is the first part and the payload data is the middle part, and then the verification signature is the blue part, and it can't verify this right now because it doesn't have my 256-bit secret. Whoops. So if I paste my secret in here, now it knows what my algorithm is, and you can see that the signature is verified, which means this information has not been tampered with. If I try to change one thing in here, make this M into an N, let's say, you may still be able to read some of this data, but it now has an invalid signature. So it's useless. Nothing's going to trust this token. And so that's how we're going to know if something has been validated, because we're going to do the same thing when we receive one of these tokens to access an API. So in the next episode, we're going to lock down an endpoint. We will get our products back working with a quick proc, and we will lock down the API endpoints, but we'll leave the token endpoints accessible to unauthenticated people. Of course, you need a token. You can't expect to already have one to get one. So that would be like an anonymous endpoint. And so we'll set those up, and we'll set up .NET Core's API middleware to look for a valid token that is what we expect. And then everything's going to be concrete there. And then we can go through the code and we can lock down some of these secrets and take some things out of code. Like we have database connection strings with usernames and passwords. Those need to get out too. So it's probably worth it to spend some time on the app settings logic and how to use it with environment variables. And maybe we'll throw an Azure Key Vault to show you how to use it with a cloud resource. Hopefully this was good stuff for you. I really love this stuff. I find it kind of fun to do. So hopefully that was fun for you too, and you can make some use of this and lock down some of your projects. And as always, if you found this interesting or helpful, please subscribe. I greatly appreciate the support there. And as always, practice, practice, practice. And I will see you soon online.